Hello, chaps. How are we? Good? How was lunch? Good. We got lunch offered by NDC. It's so nice that we have NDC back in person and in Melbourne after 3 years. I'm local. I live in Greensboro. It took me 1 hour to come here and see some real people. So I still remember, like last year, I presented at NDC Sydney, completely online, and I couldn't see the reactions from audience. I talk into camera, look into void. I don't know whether my talk was exciting or I talked the audience to sleep. You've just had lunch, maybe it's time for a nap. Hopefully I can help you digest food instead of talking you to snap. So today I'm going to talk about deployment. How we can make easier deployment using a green-blue deployment strategy. Let's jump straight. Hold on. I just noticed a mistake, a problem on the slide. Have you noticed anything wrong? Yeah, I think it's called blue-green. So what blue means is the existing current version, and what green means is the new version. You know, on the traffic light, we have green means that we have good wishes of ready to go, and we want to slowly move users from the current version, blue version, to a newer version, which is green version. So it's a mistake. It's very embarrassed. So I'm gonna, as a really agile person and an agile practitioner, I'm gonna fix it now. Really, I even have a to-do note to remind myself to fix it. You know, so it's very hard to manage backlog. Sometimes to-do would become never touch it. All right, so I've got it fixed. I do apologize. This issue would have been caught much easier and quicker if I had given this talk as a test run to a smaller group of audience a couple of days ago. Obviously, I didn't do that. But imagine if you are trying to deploy an enterprise application to a very wide group of audience or users, like tens of thousands or millions of users. You deploy a change to a production, and they're using a system. It could be a banking system, insurance system, whatever. And they your end user notices a bug where they are calculating something, they're going to divide by 0 error. They're going to start complaining. That's really bad. That's going to damage not just me, my personal image in the community, but also the image of the branding. And you're gonna lost in your competition to other competitors because they move really quickly. So we don't want that to happen. In order to avoid this sort of problem, we really want to advocate and utilize a great DevOps exercise to make sure that our changes can be handed to end user as quick as possible, as secure as possible, with less human intervention as possible so that it can be as robust as possible. I really like this small icon, which is an infinite symbol. What this means is, first of all, in a modern SaaS product, especially web-based, we always want to roll out new changes quickly. Even the small incremental in the existing system, we want it to be accessed by users so they can give us quick feedback. We never dictate what users want, but users tell us what they want, what they like, what they dislike. And this is an infinite loop, means that this process needs to be done in iterations. And so that DevOps is a glue which combines people, product, and process. Your operational team and your development team gonna collaborate closely to make sure that this entire process runs smoothly. All right, we understand the principle, but how we are gonna make it happen? Obviously, as I just mentioned before, if I wish I had done a test run to a small group of audience, that's a different setup as compared to this live presentation. So setup is also called environment. First of all, I want to talk to you guys about why we need multiple environment setup in a modern development shop and DevOps process, and how we're going to set them up, especially on Azure. Once we've got our environment set up, we want to get it moving. We want to have some strategy to deliver our software to this development, staging, whatever environment, so that they can be accessed by different group of audience, aka stakeholders or users. And then we're going to narrow down to talk about how we do it on Azure. I'm an Azure person. And then I have a small demo to show you guys a proof of concept of our understanding of this principle. Before we get started, this is my information about myself. My name is Patrick Zhao. I am a solution architect working at SSW, Victoria office. These are my social media links. You are most welcome to connect me and drop me a message if you have a common interest. I'm interested in DevOps, data, AI. Oh, one thing I want to highlight is recently, just like other developers, I like to follow great projects on GitHub. And recently, I've been leading a sort of like internal, but we open source it, project on SSW's consulting repository. It is about a chatbot that we implemented in using Microsoft Bot Framework. So it serves as a virtual receptionist. That's when the visitors comes into your office, your front desk, you can talk to a bot, and it helps you to find an employee with certain skill sets and availability. It talks to all those CIMs and etc. And I like it. I really like it, not just because of the tech. I'm into the tech. Louis, Bot Framework, all good. But also, it does the job so that a real human receptionist can focus on doing the things that only human can do, rather than being like a bridge between the visitor and the CIM systems. So come and check it out if you are interested into bot. All right. So, as I mentioned before, we want to have different setup so that we can get our product going through different stages and be really, really solidly tested before it's rolled out to our end user. For Scrum Master and for team leads, this is very important because this can advocate innovation so that your team members won't be afraid of breaking something because you always have an environment for them to play around, for them to screw up and fix, like what I did on my slide. And also, it can increase the productivity on your team. And with different environment setup, we can have a more consistent release management. What this means is, we might follow some naming convention like semantic versioning. We have version 1.1.1, and then we make a very minor change or patch, bump up to 1.1.2, and we have these changes queue up and ready to be released to staging and be thoroughly tested to staging, and you can have UAT, regression tests, or a whole bunch of different tests running on that environment, and we will have these releases ready to be shipped. And whenever the business make a decision that we want to have some releases given to user to play around or to try it out, we can, one click, we can deploy it to production. So that way, from the management perspective, this makes our life easier. And obviously, it's going to reduce downtime because the release is thoroughly tested on an environment pre-production. So we tend to have caught as many bugs as possible and have got them fixed already. And also we've tested not just the binaries or the Docker images, but also the configurations. Obviously, we need to change some of the configuration when we are actually putting something into the production. But the last stage, before we roll out to production, is in an environment that is as identical to production as possible. There are running examples, which I'll show you in the following slides, so that the downtime on the production can be minimized. And obviously, we want to have a better security approach, because when you have multiple environments set up, you can apply your policies and permissions and controls to those environments. So you would then need to expose production data. Of course, you can obfuscate it, you can hide something, blah, blah. But if developers are given an environment without business confidential or actual user data, there are less chance anything is going to be stolen. And of course, the end goal or the core of this approach is to get in the product to the user as quick as possible. An example setup is we have a development environment. Here, the development environment does not mean, or does not only mean, the machine developers work on. A lot of people might argue, like, oh, in a traditional desktop application development practice, developers would have a local machine, and then they can do some code change and F5, make sure it runs, then done. Actually, it's not done. Because the environment that runs the software might not be the same one as you have, even with desktop application. Some application would rely on some operating system specific functionalities. Then you need to have at least a VM running that particular version of operating system up and running. And in the modern web development era, we need to have multiple environments. And especially for development environment, we need a cloud environment so that we can test cloud native features when developers are working on them. A good example is Signal Service, or Service Bus, or Cosmos. There is a local Cosmos emulator, but it's always good to have a cloud version, which is quick and easy. And we want to have a staging environment, or we can call it a QA environment, or a couple of QA environment that runs different suites of tests. Integration test, regression test, user acceptance test, UI test using Selenium, Playwright, so on and so forth. And then we have the production environment where we deploy our releases to at the last step. But before we deploy to production environment, we are already relatively confident that the software is going to work in production. And in order to achieve it, there are certain strategies we need to follow, which we'll touch on later. But before we move on to more deep about how we build them together, I want to show you how we can set them up. So this is a very conceptual. So you can see that we have different local development environments on a user's machine, and then through the CI, continuous integration, the code you committed to your feature branch is integrated to the master branch and then deployed to the development environment. And then you have one or multiple test environment where you can run different suite of tests. And then you have pre-production or maybe another staging, and then you're going to have the production environment. Now, on Azure, how are we going to set up multiple environments? What are the options out there? There are actually a lot of ways to set up environment on Azure, but a more logical way or more reasonable way are one of these. First of all, Azure offers something called Azure Management Group. Management group is nothing but just like a container. So you know Active Directory, Azure Active Directory. So coming with Azure Active Directory, there's a root tenant management group, but you can create one or more management groups underneath it. They are containers that help you to manage users' permission, your Azure policy, and compliances across multiple subscriptions. And of course, there's subscription, which is a virtual wallet where your resources get billed to. You can use your credit card to organize your resources, just like how we organize our expenses at home. And there's resource groups. They are actually logical grouping of your resources. And it's very useful and flexible. You can have because mind you, this is like a virtual node or tag. This is different from the tags in Azure Resource, by the way. But it's essentially it's a virtual grouping of your resources. Whereas if you have a Azure Resource group spin up in Australia East, you can actually have resources within the resource group, which is in a spin up in Southeast or Melbourne data center. But it helps you to filter your resources and find the resources easily. So from this diagram, we can see that if we're trying to go with management group-based resource group strategy, what we can do is we can have multiple different management groups set up underneath them. Each of them will have a subscription. And then we have one or more resource groups. And then we leave the resource groups to development teams' hands to make a decision on which resources they want to group together. Some of them might want to group some application-related resources together. Some of them might want to group some data-related resources together. So as a comparison, there is subscription-based resource environment setup that we skip the management group level and we come to the subscription directly. We use your virtual wallet to organize your environments. And then we have a development, subscription, staging, and production. And then last, there's a resource group-based environment setup that we have. Essentially, we have different resource groups, and each of which has a group of resources. So this is usually when a greenfield project starts, we are uncertain like how many environments we're going to set up. So we tend to start quick and easy. Then we can use resource groups to organize our resources. Then we can have a sort of like hybrid approach that we're slowly moving into expanding our Azure setup. Like for example, we have different departments, and you can tell that the marketing department might have some resources like Logic Apps, Power BI. You only need one subscription really, because they just do some low-code stuff. But with the core engineering department, we need to have more resources and more hierarchies so that we can organize them separately. And most of the time, we want to separate production and non-production subscription because we want to monitor the cost generated by this bunch of resources because they are running at different scale as compared to a non-production environment. So that's why it gives us a flexible way to manage and monitor our cost. So once we've had all the environment set up, we surely want to govern them. What does governance mean? It's actually an analogy to how we need and why we need a government to manage the people. So it's about how we manage our resources and make sure that the security exercises are imposed throughout the setup. There's RBAC, which is role-based access control. And there's Blueprint, which is sort of like a stamp that's deployed at a single subscription level. It's a composable artifact, including your ARM template, bicep, your role and policy assignment, and also custom scripts, so that you can easily replicate your setup, spin up another subscription easily. And then there's Azure policy that can help us to make sure that we only spin up certain type of resources within our resource group, so on and so forth. And the grouping inside Azure policy is called initiatives. And we can assign policy to a selected amount of resources. Now, we have understood how and why we need to set up the environments. Here comes another topic, which is trying to get the environments up and running. A lot of us sitting here must have heard about the Agile Manifesto. It was like released 20 years ago. So it has like 12, maybe 12 principles that specify what we need to follow in an Agile development. And on the top, the primary principle is we need to satisfy the customer. The way we satisfy our customer is to have early and continuous delivery of valuable software. Now, the keyword here is continuous delivery. A lot of people is confused by continuous delivery and continuous deployment. So what is the difference? Who can tell me? Who want to give it a go? What is the difference between continuous delivery and continuous deployment?
Deployment's just getting your code in production. Delivery is actually having it used in production.
Not bad. That makes sense to a degree. So there are a lot of people, different people have different views towards it. One of the definition that I like most is from Martin Fowler. So what he said was, continuous delivery is something that is a discipline. The keyword here is discipline. that when we build a software, we build it in a way that it is ready and it can be released to end user at any time. But it might not have to be deployed to the user straight away. In comparison, the continuous deployment has automation in it, that the changes we made are automatically put into production. It will result in many deployments on a daily basis. So the difference here is whether it's automated or not. So why there's such a difference? Imagine we have a lot of increments in our software that the development team come up every day. Surely we want those to be used by user. But do we want to give it to the user 5 times a day? Probably not, because that's a business decision. So from engineering team's perspective, we want to make sure that we are ready. We are always ready to do that, but we might not pull the trigger. We don't make the decision. We need to listen to business. If the business believes that if we amalgamate 5 releases and deploy it all at once, that can give users a better way to try our software, we should do that. So continuous delivery is the process that we make sure that our releases are ready, and with minimal click, 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 we can get it done. Whereas continuous deployment is we do that automatically. And most of the time, we want to have some degree of automation, at least to the pre-production environment. So it can be a hybrid approach at the end of the day. As you can see, the deployment is something that's moving. It's automated. We want to be able to ship the goods to the user or to deliver the things to the user automatically, as quick, as automatically as we can. What are the strategies that can help us to achieve it? How many of you have heard about some of the deployment strategy? Blue-green? A/B testing. What else? Canary. Yes, exactly. So we're gonna look into these deployment strategies. First of all, is canary deployment or canary testing. Regardless of how we call it, it originated from an old mining sort of approach. Before the miners go down to the mine, they usually bring a caged canary and use it to test whether there was life-threatening toxic gas or the degree of the gas emitted down there. It was really brutal. I don't really agree. But the keyword here is whether there was life-threatening issues or not. So it's readiness check. It doesn't check everything, because we only choose a small amount of the feature which we believe is most critical or it's regression related. So we can have a quick reverse. Usually we're going to pick like 10% of the user, so that no matter how evenly distributed or how dispersed distributed that 10% of user is, it is at the end of the day, it's just 10% of the user. They're not going to cover all the use cases. It can detect problem and regression, but we also need to be mindful that there could still be other things going wrong when these changes actually released to a group, to the whole group of audience. Now, when the canary deployment strategy is running on a rolling way, then here comes the blue-green deployment. What this means is, starting from a very small amount of user, 10%, when we slowly ramp it up, we are going to move users from the current version to the newer version on slowly but steady paces. Our blue environment and green environment are as identical as possible. There has to be some database replica strategies out there to make sure that these two environments talk to the, if not the same, at least as close as possible the data schema and data sets. And in terms of implementation of blue-green deployment strategy, there were some potential traps and some things we need to look out for, such as how we design our database schema to make sure it's backward compatible, whether we have nullable columns, so on and so forth. But on a high-level perspective, we want to try to make sure that the configuration between blue environment and green environment are as close as possible. And it's commonly route-based. What that means is we have a route, either sitting at the DNS level or at a sub-route level, that we can route users to one environment or the other. And there's another good reason why we want to advocate blue-green deployment strategy. Even when we have rolled all the users from the blue environment to the green environment, we never decommission the blue environment straight away, but we leave it standby. So if anything goes wrong on the green slot or the green environment, we can quickly roll back. We still have the old version of the software. Again, data may be something tricky, but we're going to deal with it case by case. So blue-green strategy is really just like a canary strategy or canary testing on a rolling basis. There's another one, which is called A/B testing. So what A/B testing is about, it's 50-50. But not just 50-50. The idea behind A/B testing is you have a theory, or you have an argument between your teams, like whether this feature is better or that feature is better, whether we make the button blue or we make the button red. So you can certainly argue it from a statistic perspective or from the CSS perspective, but most of the time we want to have some statistics to back us up. So we run experiments. In order to run experiments, we need to have a hypothesis to begin with. And then we need to work out what are the metrics that can help us to prove the value that we collect from the experiment, which can help us to justify and to prove either A is better or B is better. So usually we call the group A called control group, and we have treatment group. And we even distribute the users to each of these features and let them play around, collect the metric, and see whether they like it or not. So this is a really scientific approach that can help us. However, the hard work here is how we can make a good hypothesis, and what are the metrics that we are going to collect and observe is quite challenging. Now, in order to implement any of this strategy, we need to be able to toggle something on and toggle something off. No matter this toggling on and off is on front end, like your HTML, or is charting from your DevOps pipeline before you deploy to environment, or on the server side, it is essentially some if-else statement. If the user belongs to the 10% of user, we route them to this environment. If it's in the other 90%, we route them to that environment, or let them click the other button. And there are certain tools that can help us to do it. There's, most of us are from .NET background. So in .NET, there's a default feature management. And on Azure, there's app configuration service. You can filter your app configuration by features, and you have dedicated feature management where you can work out the percentage and etc. And there's LaunchDarkly, they have a booth out there. They have a cool thing on Azure DevOps, which is the feature rollout step, which can be easily found as a step in the release tab. Now, in order to implement this progressive deployment strategy on Azure, what can we do? First of all, we need some network routing services to help us sitting at the front and route the traffic to different slots or group of users. There are a couple of options. There's Azure Front Door, which is sitting at a global level, and it's HTTP, HTTPS-based. It has weight-based routing rule. The second kind of application gateway sitting at global level is Traffic Manager. It's DNS-based. So you can have station.blah.net or .com and qa.blah.com. And you have weighted round-robin routing method defined so that the traffic is distributed. And on the regional level, there's Azure Application Gateway. And we have API management. I really like it because I work in microservices a lot. So usually with microservice, you always need a sort of like a facade, especially when you want to migrate services or applications from legacy to the new. You want to have a facade so that you can support your strangler fig pattern, which I touched on in my previous talk at NDC. But API management is an Azure PaaS service that does the same thing for us. However, it has a built-in app gateway that has the policies, which I'll show you the code in the next few slides. And at last, this deployment slot offered by Azure App Service. It is great, especially when we are dealing with web app, either native web app or containerized web app. So the way they work are more or less similar. Let's take Traffic Manager as an example. If we're trying to implement a blue-green deployment strategy, we start from two environments, obviously. We have the existing version running as the blue environment, and we have a new feature ready, and it's already deployed there. But we're routing only 0% of users to there for the minute. Then what we do is, via some configuration change, we're going to route the user. We're going to ramp up the number from 0% to a higher percentage, like 20, 30, or maybe 50. All right, so pay special attention to this replicated DB. This is important. It is not just a relational database, but also Cosmos non-relational data store storage account as well. You need to make sure that these two environments are talking to a data store which are identical as possible. And then, at last, we're gonna route all the traffic to the green slot. But at this moment, is it done? Sort of, but not really fully done, because you want to swap the slot. So that otherwise you have to modify the DNS routing in here to make sure that these slots represent the latest version and based on the DNS or the routing rule. And in deployment slot, we can see it offers a handy traffic management routing sort of like percentage feature that we can easily leverage to define the percentage of traffic we want to route to a particular slot. With API management, what we can do is it offers us a policy definition place where we can write some C#-like language. How cool it is. We can read it, and we will understand what it means. So if there's a canary percentage, let's say 10%, then if we generate some random number, if it's lower than 10%, we're going to route to this backend URL rather than the default one. And since we can express this logic within this policy definition in like an XML sort of style, we can surely have it in our code. It's not hard to achieve. Now, let's jump to the demo. Enough talking. First of all, I've got some code. So what I've got is I've got a front end, which is really simple. I just call a backend URL. I'm demoing the deployment slot, by the way. So I have a webpack deployed to the backend, which I'll show you in a bit. But what the front end does is very simple, whether we are hitting feature A or feature B, and we want to see the percentage. OK, so if we jump to the app and we refresh it, we're going to see that currently we are only hitting feature A because we are routing 100% of the traffic to the production slot. Now, if we come back to the code, and we quickly have a look at the backend. Backend is very simple. It's nothing. It's just a very normal .NET app. And we want to just make a change, NDC, or maybe 3. And let's commit the change. All right. So once I've committed the change and synced with my remote, the CI process kicked in. I don't have automatic trigger because I want to show you the demo. But what it does is I have a pipeline set up on Azure DevOps. What it does is, first of all, let me run it first. But essentially what it does, if we look at the previous run, is it has multiple stages. First of all, there is a build stage where we do .NET build, we build the artifact, we package it up, and then we have a deployment stage where we deploy our change to our staging slots. And then we slowly ramp up the percentage of the traffic. So eventually it gets to 100%, and then we put the trigger to swap the slot. All right, if you look at the definition of the pipeline, we have everything in code, by the way. If you look at the code, you can see that first of all, we have the build stage, and we archive the artifact, and then we have multiple stages for deployment. The first thing we do is, by leveraging the app service management task, we can stop the app service and restart it. We don't have to do it. Azure can manage it for us, but it's always good practice to do it. So it gives the other developers an understanding of how we control the flow. So what we do is that we just upload the artifact. If it's a containerized web app, what we do instead is that we flip the Docker image in the runtime configuration. And then here's the interesting thing. We want to make change to the routing configuration. I call it canary deployment, but it's essentially we're just bumping up the percentage by running an Azure CLI command while Azure CLI task. This is really handy. It handles all the authentication. You don't need to do two-factor authentications, etc. It handles it for us. Now, if you really want, there's a handy way, which is called delay. We can track in the delay in minutes so that we can have a grid, like sliding window, for us to collect metrics from the environment, like how many % of traffic is hitting which environment, whether users are happy or not, as long as we have the experiments ready. But this only runs on agentless job. What this means is that you need to have a server. It doesn't run on the default pool, which is what I define here, Ubuntu. Yeah. And you can have Chrome jobs and etc. as well on DevOps. These are all really handy. All right, so before I continue, let's look at whether my latest build is running. Oh, great, it's ready. But before we do anything, or actually, let me run the deployment stage first, because it's going to take time. Now, at this moment, this is Azure, and this is my sample web app. As we can see, it has a URL, and it has deployment slots. Azure gives us the way to add slots. We can add more slots. Currently, I'm telling Azure to route the traffic 100% to the main instance and route 0% to the stage instance. What this means is, when we are hitting the main instance, we're going to get the response, you are in feature A. We're not going to get you are in feature B. Hence why you are seeing here, we are hitting 100%, hitting feature A. 100%. Although we have a staging site, which asks for the URL, and if we hit it, the last response was B2. I think it's actually run a deployment, so it's going to take some time. Is it done? Yeah, I think so. Yeah, B3, you see? That's the latest change I literally just made 5 minutes ago, or 3 minutes ago. So we have a staging site, it's sitting on a different URL, and we're able to call it separately if we want. But if we call it from the main URL from the URL from the main app, we're always gonna hit feature A, which is the main instance. Now, excitement begins. Let's bump up the percentage. Approve. Now, why I would want an approval process is because we, usually as a team lead, you want to have sort of some control and make sure that you run the experiment in the time you are comfortable to watch the matrix. So with DevOps, you can have different environments set up here, and within each environment, you can have a bunch of gates or a bunch of triggers here. Whether we we have a policy around business hour that step attached to environment only runs within, outside business hour, or whether you want to hook to REST API, evoke Azure function, so on and so forth. This is really handy because if a development is we only want to ramp up the traffic from 10% to 20% outside business hour, so that gives users a seamless experience, we can do it while the configuration, a simple configuration with the environment. We don't have to change the YAML code in the pipeline. All right, let's come back and see how it goes. All right, the 10% is done now. Let's go back to Azure and verify it. Let me click out and click back in. Great, it's 10%. I didn't make any change here manually. It's all done via Azure CI. And now, let's prove it. Only 2? All right, let's refresh, because it's accumulated from the beginning. Forgive my CSS. It's flickering, but my math teacher tells me we need to run enough amount of experiments so you will stick to the percentage. Let's see if it will come to 10%. So the theory is that we are hitting this URL, or the URL is in the code. You've seen it before. We are hitting this URL. So the traffic would be distributed to 2 slots, 90% to the main slot and 10% to the staging slot. Or if it runs long enough, it's gonna more adhere to 10%. So for the interest of time, let's get to the next step. Let's bump it up to 50%. All right, we're gonna approve again. Now here, we've mentioned about A/B testing. With A/B testing, we probably need to flexibly arrange it. We want it to be bumped up to 50% straight away. And usually with A/B testing, we want a more comprehensive approach. We might need to have some kind of gateway sitting in front of our actual backend services. And the backend services doesn't have to be Azure Web App, containerized web app, or native web app. It could also be something like a pod in your Kubernetes cluster, or anything, or Azure function. Now, we've ramped it up to 50%. Let's have a look. You see? Very close to 10%. Yeah. So what my math teacher told me was correct. All right, so now it should be 50%. Let's witness the miracle. It should be 50%. Once we are happy with the evenly distributed setup, we can bump it up further to 100%. So I'm going to approve again. Let it bump up to 100%. While we're waiting, I'll just keep this running, flickering. So as you can see, from what I am doing, some of it can be automated, like for the deployment to stage environment, etc. But some of the steps has to be manual. Not because we cannot automate it. It is because we want it to be manually done. So we can manage the process, especially for a rolling basis deployment strategy. We want to observe the effect, and we can take actions. If production goes down after we ramp up from 50 to 70%, we want to quickly roll back. And I'll show you how easy it is to roll back just in a minute. All right, give it some time. So now it's 100%, fully routing to the staging. So an interesting thing here is, so this Swagger is the Swagger from the main instance. Let's hit the feature. Refresh. It's still in feature A, but if we refresh this one, you can see that we are 100% hitting feature B. So that means all our users are now in the green slot. So that means we are almost done with it. Only with the last step, which is we want to swap the slots, so that the green environments can officially become the blue slot or the blue environment. Because I'm demoing with the very basic setup offered by app service. If we want to have a more hybrid or comprehensive solution, you might need to tweak your API gateway done in either any of those routing solutions. But now, let's approve the change and let's swap the slot. What's going to happen is these two slots are going to be swapped. So when we are hitting the live URL, we are hitting the staging slot, well, the previous staging slot, which becomes the current production slot. Which means that we will see feature B when we hit the main URL. Let's see when it's done. It's still running. So the swap slots is done by a Azure DevOps command called, or still the app service manage task, and we do swap slots. But if we are trying to swap slots, we don't need to specify the target slot. We just need to specify the source slot. This is just some of the syntax consideration. It's going to take some time. So let's let it run, and we'll come back in a bit. In the meantime, what I'll show you is API management in action. So what does API management do is, first of all, it gives you a place for you to manage your open API definitions. It has a built-in application gateway, but also you can bring your self-hosted application gateway or leverage other Azure services. But for the purpose of today's demo, I have some API. I imported them from the main service. And you can see that I give it a web service URL, which is from the main app. And we can test it. But before we go about testing it, I want to show you the policy in action, which is from the screenshot you saw. So as you can see, it's very easy to write some code here. And whatever written here can easily be automated in code. I haven't got a running code version of it, but if we're all from Azure background, we know Azure has ARM template, bicep templates, which these things can be done easily. So before I continue, because I'm going to potentially screw up the percentage, I want to finish this demo first. So we've swapped the slots. So what that means is when we are hitting the main instance, what we're going to get is feature B. The change is actually in production. No room to regret anymore. but we've done enough testing, ramping up from 10% all the way to 100%. We build up our confidence by collecting metrics. So running experiments, getting confidence can really help us to satisfy our customers. All right, so the last thing I want to show you is API management, of course. But in order to show it, I need to have a different distribution to the apps. Oh, no. The distribution can remain the same, but there has to be a percentage here. So based on this percentage, we're gonna get routed to different instances. Because now the staging, I need to get my head around. The staging instance becomes the live instance, and the live instance became the stage instance. Let's just prove it. Just make sure that I'm in the right track. Yeah. So when we hit the stage instance, we get feature A, which was the previous production instance. So now, let's come back here and do some testing. So API management gives you a UI to test out your policy. Let's hit send. And feature B, hit send again. Feature B, send again. Send again. Feature A. So you should be following what we defined in the policy. Like only 10% traffic is gonna be hitting feature A, and the rest, 90% should be hitting feature B. So by the look of it, this API management works very similar to the staging law. Then why we even want to look at it? Why we bother? It is because this base URL can be anything, as long as it's a URL. It can be an IP address, can be a pod in your Kubernetes cluster, can be Azure function, can be Azure container app, can be anything. When we are dealing with microservice, API management comes in handy. You not only manage your API, you have your backend for front end, but also you have a routing strategy to support us to implement different deployment strategy. We don't have to use it, but this is an option for you to consider when we're dealing with large enterprise applications in microservice architecture. Oops. Come on. All right, it's coming back. All right, it's the end of the demo. Let's come back. So, as I mentioned before, in reality, the demo is just a demo, just a proof of concept. But in reality, usually we want to use a hybrid approach. And one of the way we can implement a hybrid approach is that we can bring in our own application gateway. Here it is the Azure application gateway in dealing with regional traffic. If you want to deal with a global, you have traffic manager, you have front door, or you can even spin up your own Ninjax controller, whatever, reverse proxy. But what it does is it has the routing rule, which is very similar to what API management gives. But what it does is very simple. Based on the routing rule, we set some headers or some information that we want to hand over to the subsequent API management. And in the regional setup, we have API management, and we only interrogate that particular header rather than defining the rule again. So that way, you have a centralized place where you manage your routing rule. API management's logic becomes very simple. If the header is this, route to that. If the header is that, route to that. So that way, each development team can have, or each substring of the business can have their own API management. And we can have a centralized place to manage application gateway. That makes the development team working closely with the infrastructure team if the organization is structured that way. This is just something for you to consider when we are dealing with applications at different scale. All right, time is running out. So as a bit of summary, today, first of all, I corrected my mistake on the slide. I was lucky that my talk got picked, even with a small mistake there. But in the real agile world, we want to be able to fix our mistakes as quick as we can, and we want to satisfy our audience or customer. So in order to do so, we want to have a way to set up multiple environments and a way to boot different environments up to deploy our application to, and also run tests. Sufficient amount of tests would help us to build the confidence that we wouldn't screw up the production environment. And we look at how we do that on Azure. with plenty of examples. Hopefully you have followed me and learned something from it. And of course, we did that demo. I hope you have all enjoyed. And as part of the gamification thing, we've got a booth there. You can, we have a rewards app, and you can scan it to get some good swag. You know, me, Ben, whatever. Yeah. All right. With that, thank you very much. Any questions?
You said you were going to share how you roll it back in case of disaster. How would you do that in your pipeline? So when you're ramping up 50 to 100% in your pipeline, how would you actually roll it back if something went wrong?
All right. So you can leverage that swap slot. Yeah.
When you were going from 10% traffic to 50% traffic, if you started getting errors, how in your pipeline would you roll back?
You change it to 0%. Yeah. Yeah, change it to 0%. Or you can use, like what I show you, you can use that task, or you can do it on the UI. So how you do it on the UI is from here. On the deployment slots, you can swap slots from here as well. Yeah, so usually we want to do this manually because we can have some a degree of control. Yeah.
So in your front-end application logic, it shows that it's bouncing between the two. Where in the real-world application, let's say the feature is about filtering out a list of orders maybe based on one of the business criteria. How that is going to be behaved when a user actually logs in one time, it shows a one list. If you refresh, it's going to be another list. So it's bouncing between that for the same user, right? What is the strategy that you're going to keep that user in that sort of like the 10% canary instance when you're testing that? Yeah.
That's a very good question. Just for the sake of streaming, so your question was about how we can reflect this two group of users on front end, particularly, rather than just giving a very basic statistics. I'm not a front end expert, but what it boils down to, I believe, is some feature toggling functionality. We need to leverage some feature management libraries, like what I showed before. There are some front-end libraries, and LaunchDarkly has a front-end SDK that we can hook into, and then we can design the flows. We want to have a central switch where we dictate which subpaths of the user is navigated to, not just the API URL, but also the component, slash user profile or slash user profile new. Yeah. All right, any other questions?
Have you done this with any other kind of different deployment pipeline, and if so, how did that process compare?
To be honest, so the question is whether I have done this on other type of DevOps engine or not. To be very honest, not for commercial projects, but as you probably can see, those key steps, well, one of the most important step is actually done in Azure CLI command. So no matter which DevOps platform you choose to use, you just need to find out the equivalence of the Azure CLI task. And from my experience, whether it's GitHub Action or Azure DevOps or Jenkins or Bamboo, their version of Azure CLI task work more or less very similar to each other. They just handle the authentication process, and then it gives you the flexibility to work out your own commands. Yeah, so we follow the principle. The implementation, the syntax of the code may be different. Any other questions? Again, thank you very much.